I want to determine whether these triangles are acute, obtuse, or right. And remember, the rules come from the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Now, if a squared plus b squared is less than c squared, or the hypotenuse squared is bigger than the two sides squared, then that represents an obtuse triangle. And then if a squared plus b squared is greater than c squared, or the hypotenuse is less than the two side squares, then it's an acute triangle. Keep these rules in mind as we go through and apply the Pythagorean theorem to these two situations. I'll start with the 38, the 77, and the 86. This could be a Pythagorean triple. I'm not sure. But I know that the longest side of the triangle would have to be the 86. I'm going to kind of create a wall here. First, I'll find the sum of 38 squared and 77 squared. 38 squared is 1,444. And 77 squared is 5,929. Add those two up, and I get 7,373. Now let's compare that to the c squared, the potential hypotenuse of my triangle. 86 squared is 7,396. 7,396 is greater than 7,373. So since the hypotenuse squared is bigger than the two sides squared, then this triangle would have to represent an obtuse triangle. Let's compare B, the ones with the decimals. I have 10.5 and 36.5. Both of those are squared. Again, my hypotenuse would have to be the 37.5, if there is a hypotenuse. So I will start over here on the left. I have to do 10.5 squared, which is 110.25. And I will do 36.5 squared, which is 1,332.25. And I'll add those up to get 1,442.5. Now I'll compare that to 37.5 squared, which is 1,406.25. Now looking at these two, I notice that the sum of the two smaller sides squared is larger than the larger side squared. So that means that since the hypotenuse squared, or the largest side squared, is smaller than the other two, then that would have to be an acute triangle.